All right, so maybe we can continue here, and probably your Jupyter Lab kernel has died if you're using binder and things like that, but don't worry because we're going to open a new file, and I think that will start up a new kernel for us and everything. So probably you were in this L5 directory. If you go back into NumPy, we're going to now work with this file number 2, processing data with NumPy. So you can double click and open that up, and yeah, it did start up, at least for me, a Python 3 kernel. And because we're in a new data file, Jupyter Lab doesn't know anything about what we've done in the other one. So the first 3 cells are just like click on them and do Shift Enter. This is just going to load, first off, NumPy. Then it's going to read our data file that we had from before and load that in the same way that we did previously. And then lastly, it's going to chop this data file up into the 4 different columns like we did before. So this is just kind of a quick way to bang, 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 get that kind of back to where we were at the start of this, this part of the lesson. Okay? And like before, if you've got problems, just make yourself visible and we'll come and help. First thing we're going to do here is create a new variable, a new array, where we can do some calculations. And in this case, we're going to do a calculation of finding the difference between the maximum and minimum temperature, for instance, for one of the days. So first, let's just make some place where we're going to store this information. And the way we can do that is we'll put a variable name, in this case diff, so D-I-F-F. And we're just going to fill this thing in with zeros to start with. We're going to make an array that's the same size as some of the other ones we have, but we're just going to fill it with zeros, so it's kind of a blank slate to start doing things. And we do that using the np.zeros function. And what it expects when you use np.zeros is you tell it how big should this thing I'm going to fill with zeros be. So we can say it's going to be the length, or len, of date. Just one of the columns out of our data file. They're all the same length, so it doesn't really matter. So np.zeros is going to fill this array with zeros. And how long should that array be? Well, it's going to be the length of date. So if you run that, again, you won't get any output, but if you print out what diff looks like, you should then see a list of zeros. And if you want to count them, there's 30 of them there. Feel free. So we've got this empty array now. Let's do some kind of calculation. What we can do is we can say, well, for instance, diff equals temp max. So we already have this defined, the maximum temperatures, minus temp min. So this is going to give us the kind of I don't know, the amplitude of the daily temperature variation or something, right? How much of a difference there is between the high and low temperature. So you run that, you don't see any output, but if we print out what is in diff now, we get something different. And what you'll see there then is the difference between the maximum and minimum temperature for each one of the days of June in 2016. So at least in Fahrenheit, there's, in most days, something like 15 degrees difference between the minimum and maximum temperature. So pretty easy. We just subtract temp min from temp max. We don't even actually have to create this array full of zeros first. If we're dealing with NumPy arrays and doing math based on NumPy arrays, when you do some calculation, what you get back out with a NumPy array is another NumPy array. So if we wanted to do something like maybe figure out what's the difference between the minimum temperature and the average temperature for the day, we could do diff min equals temp minus temp min. So this is going to just, we haven't created in advance diff min, but we have temp, the average temperature. We have temp min, the minimum temperature for the day, and we just take the difference between the two. And if we print that out, then you see the difference between the average temperature and the minimum temperature for each day. And of course, it's not quite half of the difference between the maximum and minimum, but it's similar to roughly half of that value. So we didn't have to create it in advance, because when we take one NumPy array and subtract another NumPy array, the output will be also a NumPy array. And if you wanted to check that, you could, for instance, look at the type of diff min, and you would see type diff min is a NumPy ND array, just like we would expect. So that's handy because you can do that for other calculations as well, and you don't have to make the place where you're going to store the data in advance. In other programming languages, if you want to do some calculation with an array of values and store it in some new array, you have to create that new array first and then store the values. NumPy or Python kind of handles that for us. So if we wanted to go into the realm of more familiar temperatures, we could do something like convert all the temperatures we have in temp into their equivalent values in Celsius, and we can do that in one single line. Pretty easily. So let's make a variable called temp Celsius. What we're going to do here is we're going to take our values in temp and subtract 32 degrees. And then we're going to divide those values by 9 divided by 5. So this is our conversion factor. We've dealt with it going the other way, and we've dealt with it this way. So temp minus 32 divided by 9 over 5, or 1.8 if you want to put that instead. And that should give us our temperatures in Celsius. Again, since we're working with a NumPy array here in temp, the calculations that happen here don't happen to a single value in temp, but to all the values in temp. And then, of course, the output will then also be the same size as temp. So if we print out what temp Celsius is, we now get these numbers back here. So before we had temperatures, I don't know where the last time we saw temp was. I guess we haven't really seen it recently. But first temperature was something like 68 degrees Fahrenheit, and that's 18.6 Celsius seems about right. It might not have been quite 68, maybe it was 65.8 or something like that. But that's about right then for that conversion. So this looks like it's worked properly. You can see here that we have 5 values from top to bottom here and 6 across, so that's our 30 numbers. So we've got the same numbers that we started with in terms of the number of values. Everything looks good, and this is a NumPy array that's been produced as output. Do you have any questions about what we've been doing here with creating some arrays and storing values? As I've already said, the kind of general rule is that if you do some math with a NumPy array, you're going to get a NumPy array out. Unless you do something like sum the values or find the mean, then if you do something like multiply, add, divide, generally speaking, you'll get a NumPy array back out. So you often don't have to make this thing first. You can just do the calculation, and it will be created when the values are assigned. So we'll deal with this a bit because you're going to do some calculations where you've got different variables in a data file you've read in, and you want to calculate something based on those. So you'll get some practice with that. So next thing we can move on to is called filtering data. And this is, we'll see how it goes. This is a little bit of a complicated topic in a sense, because what we want to start doing now is taking some subset of temperatures out of our list of temperatures, for instance. So the first example we'll see here is where we want to calculate the warm temperatures in quotation marks, meaning things above 15 degrees. And so we're going to create a new array called wtemp that's going to contain the values that are for temperatures above 15 degrees. So wtemp, or wtemps as it is going to be equal to temp Celsius. And so we're going to work with the temp Celsius since we've just created that, and since Celsius temperatures are more familiar anyway. So we're going to do a temp Celsius, and then we're going to do square brackets. And the reason for this is we want to specify within temp Celsius the values we want to deal with meeting some criterion. In this case, the criterion is that temp Celsius should be greater than 15.0. So what we expect to get back here in wtemps are the values from temp Celsius where the temperature is greater than 15 degrees. If it's not greater than 15 degrees, that value will not be included in what goes to wtemps. So this is going to cut out some of the data that we had before. If we were looking, for instance, at like annual temperatures in Helsinki, we wanted to figure out how many days of the year is it below freezing on average. We could do something quite similar where we just check and say, you know, temp Celsius less than 0 or less than or equal to 0, and we could then come up with the freezing temperature days. But again, if you run this, we're just doing an assignment. We don't get any output. If you want to see what's in here, we can print wtemps. And what you get back now is a shorter list of temperatures. So now it looks like there's 1, 2, 3, 4, 5, so 17 days in June that had an average temperature above 15 degrees in 2016. And if you look here, of course, these are the temperature values themselves, so you shouldn't find a number in this list that's smaller than 15. Everything that's smaller than 15, it's basically been dropped, and this is only what's left over. So kind of what we expected. Does this make some sense how this is happening? Yeah, that we're just listing inside the square brackets here some kind of criterion. It doesn't even need to be something based on temperatures. We could say we want to take the temperatures in Celsius when the date in June is less than some day, or when the maximum temperature is above some threshold. It doesn't necessarily need to refer to the same variable, as we'll see here in just a second. So yeah, we can do that. We put in some test, temp Celsius greater than 15, and that will give us those values. We can also combine the conditions. So if we wanted to say, like, in the second half of June, so in the dates of June that are from the 15th until the end of the month, how many days or which days did we have temperatures above 15 degrees? We can do that. So we could do a wtemps too. Just, real creative name here. It's going to be, again, based on temp Celsius, because we want to do something where we want to get the temperatures out. So that's the thing we're going to list here. And our conditions, in this case, because we have 2, inside the square brackets, we're going to put the conditions in parentheses. So our first condition will be like it was before. Temp Celsius is greater than 15 degrees. So that's enclosed in one set of parentheses. Okay? That's going to ensure that we get only values with the temperature above 15 degrees. But we're going to then put an ampersand outside of the parentheses and list another condition that has to be met. And that is, in this case, in the second set of parentheses, the date must be greater than or equal to the 15th of June, 2016. So in this case, 2016 for the year, 06 for the month, and then 15 for the day. So we only want things that are from June 15th on in terms of our W temps 2. Does that make sense? Yeah, I mean, same kind of, just an extension of the idea. Having two conditions makes it a little bit more complicated, but we should expect that any warm temperature in the first half of June won't be included in this list. Yeah.
When I want to do more than 2, so it's always with this and thing.
Yeah, you can add more conditions if you want with just an ampersand, and you just keep putting them in parentheses.
It's always with the same, with this.
Yeah, I think that's right. I mean, essentially, this is a logical and operator. So it's like if you take everything that meets the condition of being temp Celsius greater than 15 and everything that meets the condition of being in the second half of June, and you kind of lay them on top of each other, only the things that meet both those conditions will come in the output. There are reasons why you probably don't want to use more than 2 conditions, mainly that it just gets very difficult for the person looking at the code, including yourself, to figure out what's happening. Sometimes it's easier to like go step by step and just single condition cut things out. You can do 2 at a time. I don't suggest doing more than 2 at a time because, in my experience at least, it just gets confusing. But yeah, I mean, for instance, you might want to trim out high and low temperatures with 2 different conditions. So you say, I only want things that are like above this or below some threshold. That's a good case, but if you start adding in others, it gets a little bit cumbersome. Anyway, if you run this W temps 2, and like before, you can print it out, or if you just type W temps 2, if you're looking to save a few keystrokes, you don't have to type print. You can just type W temps 2 and hit enter. And what we see now is that we've got 9, 10, 11, 12, 13 values. So almost every day in the second half of June was greater than 15 degrees, but there were a few days that were below. So we've been just kind of chopping stuff out of our data set that we're working with. And yeah, that brings us here, and this is where things could get a little bit interesting. What we've been doing, kind of, it's sort of a hidden step in what we've done at this point with putting in these conditions, is we've been basically creating something called a mask array, and then using that to take out some piece of the data that we're dealing with. A mask array is basically an array of true and false values that say whether for each item in the array you meet some condition. So if it's being above a certain temperature, you would have for each item in the array a true or a false value that says whether you're above that temperature. Now, if you want to do something like just make a simple thing like W temps, where you just meet one condition, you can do that. If you have something like the temperature condition, but you also want to take out dates where the temperature is not above some threshold, it's useful to use this thing called the data mask. And so I'll show you an example, and we'll see, whether it seems to make any sense at all in just a moment. So if we go back here to the idea of temperatures above 15 degrees, we can make something called W temps, and I'm just going to add mask in here to the name. And W temps mask is just going to be the condition that we had before, and that is that temp Celsius is greater than, is greater than 15 degrees. If I take this temp Celsius greater than 15 degrees thing by itself and run that, so I'll just put it in the cell beneath here, just copy paste, put this down here. If I run this command, temp Celsius greater than 15 degrees, what I get back is true and false values. So for each place in temp Celsius, it checks and says, okay, is temp Celsius greater than 15 degrees at this location? And so you get true, 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 false, 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 whatever. If you then assign that to something like what we're doing here, to W temps mask, then we just have this variable called W temps mask that is true and false values. In this case, true means we've got greater than 15. False would mean that we don't. So it's less than or equal to 15 degrees. So how is that useful? Well, we know that we can make W temps already pretty easily, but if we want to know the dates when the temperature is above 15 degrees, we can do that by saying, for instance, W temp dates. So the days when it's more than 15 degrees equals date, and again, we're going to use square brackets here with W temp mask. So this is only going to put values into W temp dates when the value in W temp mask is true. And the value in W temp mask is only true when the temperature is above 15 degrees for that day. So essentially, this is kind of a quick way to figure out which days we're above some temperature threshold. We could do this another way if you want to. There's a reason that we're doing it this way, and it has to do with the exercise. So we're going to go with this for right now. So I've got trouble here. W temp mask was not found. Oops. W temps mask is the issue. So, and then if you print out now this W temp dates, what you should see are the days in June that were above 15 degrees Celsius. So we see, for instance, the 1st, 2nd, and 3rd, and then there was about 10 or 12 days that were cold. So all the way until the 14th of June, it's below 15 degrees for the average temperature. If you look at W temp's mask from above up here, we see true, 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 and then a whole bunch of falses in a row. So this corresponds like 1st day of June, 2nd day of June, 3rd day of June, all true. 4th day, 5th day, 6th day, those are all false, and so that's why they're not showing up here in the list of dates that meet our criterion for being more than 15 degrees. Does that make any sense at all, how this works with these mask arrays? Because I could also draw something on the board if you'd like to kind of see just a visual illustration. I'm kind of a visual person for how I like to learn things, but well, we may sacrifice the very end of the lesson to do it, but let's draw on the chalkboard a little bit if I could. I guess the other thing we can see here, for instance, is that if we look at the length of W temps. My kernel died. So again, if that happens to you, you can just click on the no kernel thing up there and restart it. Unfortunately, you will have to reload the data that is being used. So I'm going to go up to the top and just quickly redo that. And I think I have to deal with defining W temps again. Temp Celsius is not defined, so I've got to define that again. This is what's annoying about Binder, but anyway, if you look at the length of W temps, for instance, it comes back with 17. We know we lost a bunch of days here, and we can see that the length of the dates here is 17. So, and the W temps or W temp dates would give the same output. I'm not going to worry about that too much. But there's a few other things we should talk about. We don't have too much more to go, but there's a few other things we should talk about that are important for the exercise for this week. One of them is about removing missing data or bad data values. So we've seen these nans before, the not a number that comes up in some cases. And when you have those, oftentimes you want to get rid of them because they're not so useful. If you try to calculate, for instance, the mean value of an array that has a nan value in it, it will tell you nan for the mean because it doesn't know how to handle doing a mean with a number in there that's not actually a number. So we could make something like a little array just to play with this bad data, since we don't have a data file that actually has anything bad in it. we'll make one. And so let's say we said something like bad data equals np.zeros. We'll make an array full of zeros. It's the same length as date. So this is just an empty array full of zeros, same size as the other arrays that we've been dealing with, like date and temp and so on. What we're going to do in bad data is, right now it doesn't have any bad data, but we'll make it have some. So we'll say bad data at locations. So if we want to refer to locations, we're going to put in this square brackets. First 5 rows, so 0, colon 5, or just colon 5, equals np.nan. So what we're going to do is put in not a number values in the first 5 rows of this bad data array. And if we want to confirm that that all worked, we can just print out bad data. And you should see that you have all zeros, but the first 5 values are nan. So this is kind of a toy example because we don't have an easy data file prepared to deal with loading in bad data, but you're going to get this experience when you load the data file for the exercise this week, that there will be some nan values in there that you're going to want to eliminate. So yeah, if we wanted, for instance, to mask the cases where we have bad data, we can do just like we did before, make something called bad data mask. And it's going to be equal to the case where bad data, the array we just created, is actually not bad data. So we're going to use a different little thing here called np.isFinite. It's a function that will give us cases where the number it encounters is a finite number, meaning it's not nan, so it's not a number, and it's not infinity, positive or negative infinity, which also is not something that is represented as a number in NumPy. If it gets anything else that's a numerical value, then it's going to say true. If it gets something like a nan or infinite, it's going to say false. And so this will be our mask that we're going to be using to eliminate values. And if we print out bad data mask, what do you expect to see before you hit enter? What's the expectation here? False isn't true, yeah? So where should we see false and true? Yeah, right? If this thing works the way it's supposed to, the first 5 values should be false and everything after that should be true, because we've got 5 nans and then a bunch of zeros. And sure enough, that's what we see. First 5 are false, everything else is true. How is that useful? Well, the way it's useful is because let's say you've loaded in your data file, and your data file contains not a number values for certain temperatures for certain dates. So let's say we've got a simple data file with 2 columns. One is dates, the other column is temperatures. Some of the temperatures you just don't have data for that day. Sometimes it happens if you've got a weather station, it breaks down and there's either data missing for a day or a few days. Sometimes, depending on where you are in the world, it could be gone for years. When you go into these databases and pull out the data files, you don't know how complete the record is. So often you've got to cut out the dates when things aren't looking so good. So for instance, if we went here, we could say make something called good dates, meaning the days when we know we've got good data, by using our dates with the bad data mask. So in this case, we're assuming that in bad data mask, That's telling us times when we've got missing values or something wrong in our data, and we just want to cut out any data that has a nan for that row. So if you think about it in terms of like a spreadsheet, if you've got a spreadsheet with all these different columns for things like temperature, minimum temperature, maximum temperature, you might want to go along and say, okay, if any one of these rows has a nan in it, let's just remove it from the data set because we can't deal with this this data. Here we've got some case where we say the first 5 rows we've got bad data. I've got a problem here that this should be date and not dates. So good dates is equal to date with bad data mask. And then if we print out good dates, we see that starting on the 6th of June, we have all of the other days, which makes sense. We've taken out the first 5 days of June with our bad data mask. A case that you're going to deal with is things like if you look at temperature data from one of the files, you're going to find there's at least a few values in there where there's NaN. And you're going to want to go and remove the date that corresponds to the temperatures that are NaN, as well as removing those temperature values from the data file that you load in. So you'll get to deal with this exact process, and just keep that in mind. You can come back here to the lesson to see. Yeah?
Is there a way that you could display the dates for the days that have bad values or no values?
Yeah, you can also do it the other way around. So like if you did, there's this NP is finite. If you were looking specifically for like not a number, there is an NP is nan. So what that would do is, like if I said bad data mask 2 equals np dot is nan of bad data, it's actually going to give us just the opposite, that it's going to be true for the first 5 and false for all the others.
So what if, is there a way that we can use the previous mask that we already have?
You could, yeah, I mean there's a logical not operator, so you could just take the not of what you already have. So if you've created all the finite values, you could take the inverse of that, or the kind of logical opposite of that. So if we make another one here, I'll just add a Python cell and say bad data mask 3 equals, it's the tilde character, which I never can find on the Finnish keyboard. Is it this one? There. And you do tilde and then bad data mask. I think that will do it. So that's the kind of logical not operator. And if we print out bad data mask 3, we get the kind of expected result. And if we just wanted to confirm, bad data mask 2 equals bad data mask 3, we see that they're all true in this case. There could be a case, for instance, if you check to see if you have finite values and then check to see if you have nan, you could basically isolate finding the things that are infinity, positive or negative. I mean, there's lots of different kind of logical combinations you can use to play with this stuff. But most of the examples actually I've found about how to deal with this problem, we're doing things like using the not is nan setup, but I thought that was a little confusing. So this is finite, I think, is a little bit more intuitive, although this is all a bit, getting into kind of details. Okay, so we've got a couple things we need to talk about just quickly, and then we can move on to a quick preview of the exercise and other things. The mask stuff might take a little bit of practice to get used to. You'll get it this week, and if you've got questions, we can give some more information in Slack or however you like to discuss things. So one of the things you're going to have to do this week is also deal with things like rounding your data. So for instance, if we wanted to round our temperatures in Celsius to the nearest whole number value, we can use a function called, well, it's actually a method called round that's built into NumPy arrays. So we could say, for instance, temp Celsius rounded equals temp Celsius dot round. And when you use this round method, what you should list after that is the number of decimal places you would like to round the number to. If we want to go to whole number values, then we would do temp Celsius dot round 0. And if we print out temp Celsius, it's getting a little long variable name, but temp Celsius rounded, and you print that out, and you see indeed the values have been rounded to the nearest whole number. So they've not been truncated. So you could convert this to an integer directly, but you might remember when you do this integer conversion with a decimal value, it just chops off the decimal point. It doesn't actually round. So even if it's 18.9, it just truncates it to 18.0, or well, just 18 with no decimal point if you convert to an integer. This is better to do round if you want to first round to the nearest whole number and then convert to an integer. That saves you from possibly chopping off the important part of a number. Once we've got this, we can also do something using a function called unique. And what that will do is allow us to find how many different temperature values do we have in our array. So for instance, with temp Celsius dot rounded, if we want to know how many unique temperatures we have, we could say something like unique equals np.unique, so that's the name of the function, of temp Celsius rounded. I'm just going to copy and paste this just to save a bit of typing, because it's getting to that point in the lesson where typing skills are starting to fade. And if we print out what's in unique, what we'll see is only values that are unique. So if there's a repeated value in here, for instance, in temp Celsius rounded, you can see 19 a number of times. Those repeated values get dropped out. We're left only with the values that are unique. Why is that useful? Well, sometimes you'll have things like in a data file with, for instance, climate data. You'll have different weather stations or climate stations that are listed there. And you might want to say, like, how many different climate stations do I have? You can basically go through the column, use this unique to figure out what the different climate stations are, and you could even then start taking out values based on which station they're associated with. So if you had, climate data for Finland with different cities, like you will for the exercise this week, you can separate out the values for different weather stations based on this station ID, and finding out the unique different station IDs you have is the first step to seeing how many different stations you're dealing with. Okay, so let's make our final push here into saving our output. So at this point we've read in a data file, we've done a bunch of different kinds of manipulations of the data file, and now we come to the point that we'd like to save our data to an output file so that we can either work with it again in the future or turn it in for an exercise to show that you did your homework. First, what we've got to do is make a new array called new data, because right now we have things like, we'll just take 3 columns as an example: date, temp, and temp Celsius. They're all these one-dimensional single column values, and we'd like to put them together into 3 columns in a single single data, like a 2-dimensional data array. So we can take our new data, this is going to be our array that we're creating, and we can say it's equal to np.vstack. I'll explain what this does in just a second. 2 sets of parentheses, and inside the inner set we're going to put date, comma, temp, comma, temp, Celsius. These are the different columns that we're going to stack together, and although we tend to think of them as columns because that's the way that we read them into the data file, when you deal with them as 1D arrays in NumPy, they're actually treated like all being part of one row. So VStack is a vertical stack, which says we're going to take the stuff from one row and then add to it the stuff that's in the row beneath it, and then stuff to another row beneath that. Vertically just stack these 3 rows of data together. So when we run this VStack thing, we can now print out new data. And what we see is our dates, our temperatures, and our temperatures in Celsius. But they're all right now as 3 separate rows. If we want to get back to something similar to the format of the data we dealt with initially, these were columns, not rows. So what we need to do is flip the rows and columns in order to be able to do that. And for that, there's a function called transpose. I'm just kind of pushing through telling you about these things because you'll get to practice with it, and until you start doing it yourself, working with your own data files, it's probably not totally intuitive. But what we can do is say new data is equal to np.transpose. If you've done any kind of matrix algebra before, I don't know if anyone has had kind of matrix algebra or vector calculus or whatever. Transposing things is not that uncommon. We're just flipping the rows and columns, and we're going to transpose, in this case, new data. So we're going to take that, transpose it, and just reassign it to the same variable name we started with. And if we print that out, ta-da, we get what we expect. We have dates in the first column, we have temperatures in Fahrenheit in the second, and temperatures in Celsius in the third. Everything looks to be in the right order, and life is acceptable. I don't know if I call it good, but it works. It's doing what it's supposed to. So now we formatted our data in the format that we would like. The last step is just to save it, and fortunately saving the output is pretty easy. In this case, we're going to use something called np.saveText. And what it's going to expect is first a file name, then what you want to save, and then anything that's kind of an optional value. So here we'll give a file name of converted temps.csv. I guess you've seen CSV files before. Comma separated values, yeah, pretty common text file data format. What we're going to save is our new data. So after we list the file name, we'll then put new data. And we're going to give it one extra bit of information, and that is that we want to specify the delimiter. So the thing separating the different columns, in this case, is going to be a comma. If we call it a CSV file, it's nice to use a comma to separate the values, true to the name of the file. So if you do that and hit Shift-Enter, you'll see now you get this converted temps file over here where we've been working. And if you double-click on that, it opens up in the data viewer in Jupyter Lab, and you get all these numbers with way too many decimal places. But we get the data that we expected here. And actually, it looks like in this case it's even gone ahead and put the first value as some header. We, I think, could include, if we wanted, a row of headers for the names of the data. I don't remember how to do it, but let's take a quick look here just because this might be a useful thing to do. So if we do help for np.saveText, you can format things if you want. Header equals, footer equals. So let's see if we can do this. Let's go ahead and go to our save text command and add in here header. You don't have to necessarily do this if you don't want. But we'll add in header equals year moda, since we've kept the original data format for that. Year moda, comma, temp, comma, temp, underscore C, whatever. Just putting something in here for the header. I guess, without reading the documentation, that this is going to be what we expect, that we get this header line written. So run it with this additional header thing in there, and open up our data file again. Things almost look right. I don't know why there's a number sign in front of the year moda, but now we've added in this extra line with the labels for what each of the columns contains. That's not a bad thing. It's easy to sort of skip that line when you read the data file in, and it's nice to have it there so that it's clear what these columns are, since otherwise it's just going to be a file full of numbers, and who knows what that means. Yeah, I don't know why the number sign was there, but maybe that's not something to worry about. That might be specific to the yeah, it's got a number sign there. All right, I don't know, but don't worry about that for now. Anyway, are there any questions? I know I kind of rushed through this stuff about the saving the data and things like that. If you need to go back and take a look at it again, you'll see there's a little bit of, a couple steps in there, stacking the different rows together, flipping it, and then saving. It's not so bad, but you might have to look at it once again. The last thing we can do here is take a quick look at the exercise, just briefly, because I'm very much aware of what time it is. And that said, it's kind of important just to have a sense of what you're going to have to do this week. Exercise looks like this. You might have already cloned it. There's two different versions, one for pandas, one for NumPy. I would urge you to do the one with NumPy. That's going to be to your benefit. And if you click on the link, it will take you to that version of the exercise where you can see there are 3 problems. Somewhat similar to like what things have been, the way things have been set up before. One is basic statistics from some data file. Another is about data manipulation, and then there's one about doing some data analysis. What we're dealing with this time is a data file from the U.S. National Oceanographic and Atmospheric Administration website. So you can go there for yourself if you want and pull down a data file, and it'll come same kind of format. If you look at it, it's pretty messy. So I think there's something like 30-some columns, and many of them have these asterisks in there. The asterisks indicate that there's missing data. And all of these different things you can find in the documentation descriptions of what all of these different headers mean. So I'll let you kind of have a look at that. But for us, for our purposes, we're going to load the data file, but we're not going to load the entire data file, because in NumPy, things like dealing with the columns with these asterisks in there is kind of a hassle. In our case, we only need to deal with a few columns. We need this USAF, which is the station identification number for the station we're dealing with. There's 2 of them in Finland here that we're dealing with, one in Rovaniemi and the other here in Kumpula. Then there's a date column. In this case, we have year, month, day, hour, and minute for when these observations were taken. What you'll see is that there are multiple observations per day. So that is one thing to be aware of. Then we've got temperature, we've got maximum temperature, and we've got minimum temperature. Those are the 5 things you need to worry about. When we read the file in, we can use this thing called use calls in NumPy to use only certain columns from the data file that it reads in. So if we go back just for a moment here quickly to when we read in our data file to begin with here, we could say like, well, we don't really care about the maximum and minimum temperature. We only really want the date and the mean temperature when we load our data file in. We would do that by specifying use calls equals 0, 1. So it's going to take the data in columns 1 and 2 and only read those into our variable called data. If I do that, I don't necessarily see anything different here, but I'm going to have a problem when I try to do these temperature assignments of temp max and temp min because I haven't read that data in now. So I get an error message saying that this index is not in the range of data. If I just print out what is in data, I see I only have my 2 columns. So you're going to want to do this exact thing using this use calls with the data file that we have for the exercise to say I only want the column that has USAF, the year, month, day, hour, whatever, and then temp, and then there's some max and min. The way to do it, if you were me, is just to count the columns and say this is 0, this is 2, and you just go across and then you know which column numbers to load in, and you can use calls, parentheses, in those column numbers, and it will load in just those columns. There will still be some missing data values in places, but you don't have to deal with the fact that like for a lot of these things with the wind speed and whatever, most of it is just missing data, and you load in all this data that you don't actually end up needing to use. So what are you going to have to do? Well, the basic statistics problem, you're asked to do some kind of, I mean, I don't know if these are kind of simple things, but what are the dimensions of the data? What's the data type of the data, and things like that. It looks like actually maybe there's the column names here. You don't need to include that. You can just answer the questions that are here. So just the dimensions and the data type. Then you've got to find the mean, standard deviation, and the maximum temperature, and the number of unique stations. So we've seen how to do that kind of stuff. And then if that all works, when you do these print statements, you should see what you expect. For the second part, we're going to clean up the data a little bit. And so that's going to start out by first creating a new column with the temperatures in Celsius from temperatures in Fahrenheit, because of course they come in Fahrenheit. And so you're going to do that. And then you're going to do some data selection. In this case, what we want to do is separate out the information from Kumpula and the information from Rovaniemi into two separate NumPy arrays. So then once you get things split into two separate arrays, I think maybe in here I might have skipped over the spot where you can drop out the values for temperature that are missing. Then the data analysis part is basically to calculate average temperatures for the different months in May and June for Kumpula and Rovaniemi. And then at the very end, you're asked just to kind of wave your arms a little bit about the difference in temperature between these two different locations and what that means. It's not really kind of detailed questions, but just these kind of, is there a large difference in temperature between the months, and is Rovaniemi a much colder place than Kumpula? I think we've covered everything you need to do that. It doesn't mean it's going to be pain-free, but I think we've covered most of what you need. If you have questions, you can always post those in Slack. And if we find things that are useful hints, we will update the hints for the exercise on the course page. Do you have any questions? Yeah.
When you use colors, and you've got the colon, do you put like 5 and then comma 8, comma 10, and that's fine? Or do you
Yeah.
do separate ones?
You just separate them by commas. Yeah. So you put them in parentheses and separate them with commas, and yeah. Yeah.
You also say when, I don't know, when you have maybe like 100 lines or something, a big number, that you can say just call the line, then they give the title in the head, and it just calls this line with this title in the head, or
Yeah.
to count.
It's possible to do it. It's not that straightforward to do in NumPy. And part of that comes from the fact that you have, in NumPy, the different data types can't be stored in one single structure very easily. So I actually started writing the exercise trying to do it a different way, where you could actually use the names of the columns to refer to things. And in some ways that's easier, but then when you go to add in a new column of data, it's really not nice in NumPy to do that with the column names. So pandas is something where it is much easier to do that. I think in NumPy there are ways to give the head, like the name of the header, if you know that information, and select only those columns, but I didn't envision doing it that way for this exercise. So the unfortunate reality in NumPy is that sometimes things seem really easy, and then you go to do it and it's not very easy. So anyway, yeah, if you have questions, let me know on Slack, and I think both Thursday and Friday there should be someone at the work sessions that can help with the exercises and things like that. So good luck, and see you next week.